So on page 13 with those positive and negatives, as you look at the bottom of page 13, does this make sense that this is a model for 4x if you write this in your notes, plus 6? On the other side, I don't need you to model this right now because I don't know if we have 10 tiles in ours, but that is 10 plus the 2x. So write in your notes, just so you can see what this model is. And I want you to notice what it says. Second thing that it says as we are looking at this, Rashad, is that we are going to do what? Step 2. What did they say? So if we take away these 2 x's on both sides, that means I'm going to remove these 2, right? They're gone, so I just have the 10 now. And on this side, I'm going to remove 2. And if I do that same step of removing 2, I am now left with 2x plus 6. Because today what's going to happen is we're going to have variables on both sides of our equations. And I have people do some stuff. So are you writing this one down? So you want to have 2x plus 6 is equal to 10. Some of you aren't with us. I know you're monkeying with those tiles. I know it's kind of hard when they're on your desk. So then what do we do? Step 3 says to do what, Olivia? So we're going to take away 6 on both sides. So if we take a look here, we're going to take away 6 of them. And then we're going to remove the 6 on this side too. So we're taking those away. And we get 2x is equal to 4. Which means each x value is how much? Each x is 2, right? Because we can see directly across there are 2 of them for each one. Now, we're not going to do a ton of these modeling, but I do want you to take a look at a couple of them. And we're going to do this first one right now. So I want you to make a model of that first one on the top of the next page. What do we mean by that model? That's where you and your partner are going to show me 9 plus 2x on one side. So get 9 of those ones, right? Those are our positive ones. So I'm going to see 9 of them. And then I'm going to see 2 x's, right? On the other side, so do this right now with your partner, okay? Okay? So we have this equation, right, up here. What's the least number of x's that I can remove from both sides? Abby? 2. I can't remove 3 of them, right? So please remove 2 x's from both sides. If I remove 2 from one side, I must remove 2 from the other side, okay? So what does our new equation look like for number 1 that we would write? We now have what over here? X. So let's write that as x plus 1, right, equals 9. So 9 equals 1 plus x. Our x is over here, plus 1. I am now looking at this one, and Hunter, I want to get the x by itself. So I have x plus 1. What am I doing to get rid of the 1? I'm minus 1. And I'm actually going to take it away up here, right? So if I take away 1 on this side, take away 1 on this side, what am I looking at for a solution if I look at this one? I should now have x equals to 8. Right? We remove 1 from both sides. I want you to model the second one. And then we're going to talk about that one in just a minute. So do that second one. What we really want to do to get rid of this negative x is we need it to be a 0, so we have to add 1 to both sides. So I'm going to add 1x to this side, and I'm going to add an x to the other side. My new equation, Sam, would now be what? How many x's? 4x, still minus 2, right? Equals 6. But now when I added that x, what do I have? What do I know about this right here? Negative x plus x. It's 0, right? So that canceled. By adding that x tile to both sides, that canceled out that side. And so now as I look at this problem, what do I need to do now, Rowan? Because I really don't have these x's here. What do I have to do now to get rid of to get all the numbers and to get this? I have these 2 1s on this side, and they're negative. What do I have to do to get I can't remove two negatives on this side, right? Because I don't have. So instead, we are going to add 2. Add 2, please, on both sides of yours. And someone said, why do we have to do this, Mrs. Thompson? I get these equations. For some of you, this visual kind of will help you a little later when we do the problem. So at this point, we have just added 2 to both sides, right? That's our addition of 2. We now had 4x equals 8, which means our x value should be each x, if we were looking at those and we were removing all these, right? What would each x be worth? Each x is worth 2, right? Across from each x, we see 2. X equals 2, okay? Now, again, we are not going to be doing a ton with these, but again, just to model this negative, let's take a look at this one on the top of the next page, and then we're really going to kind of get you started on your homework, okay? We'll do one example, and then we're going to first. They just didn't, as you were looking at that. Does it matter which one came first when we are writing those? No. As long as I have 2x, and then I want you to put plus -1 right below that, okay? We are then on this side having -4 plus 3x's. So we're going to take away the least number, so always wherever your smallest value of x is, they remove 2 x's, and on this side they're removing 2. X plus, so that's 1x, a -4 equaled -1. Notice we then, in order to get rid of the negatives, had to add 4. So this is x plus 0, agreed? When we add those 4. On this side, how much do we have? 3, because these two make it 0, right? And so each x value was 3. Now, I know some of you, this helps you, and some of you are like, Ms. Thompson, this doesn't make any sense. I hate doing this. Okay? I just want you to keep in mind that we always have to add the negatives to make it positive. So again, if we look at this one, 6 minus 2x on the top of that next page, 6 minus 2x was equal to 8. In order to get this to be a negative, now do we always do this when we're solving? No, a lot of you would have subtracted 6. But what happens for a lot of you is you get rid of this -2. So could we add, in this case, add 2 positives? So if you'd write this, 6 minus 2x plus 2x is 8 plus 2x. So when we look at this problem, as you look at this one, I just want you to see how they're doing this one. It's a little different. So it says if we add 6 positives to the x's, we now have, and we take away 6 once. So we take these 6 away, right? We have 0 equals what on this side if you take them away? How many x's? 2x plus, we took away 6 of them, right? So we now have plus 2. And here's the thing that some of you will do at this point. You move this equal sign that's right here, and you agree that this is 0 equals 2x plus 2, and some of you will make the equal sign right here. You'll just put it where this plus sign is, you'll just go, yeah, that's an equal sign now. And that mistake will carry over for some of you into many different places. So you need to just be really careful. Keep your equal sign. Sometimes you get it equal to 0. That's okay. What would we do now to get rid of this positive 2? We are going to minus 2. So they added -2. So we get -2 equals 2x. And each of these x's is going to be equal to -1 equals x. Now again, if you think about some of our checks and when we are doing the problems that we could check those, what we are going to do right now is I'm going to hand out a piece of paper. We're not going to practice these too much more. I'm going to have you put your algebra tiles back in your bag.